In this video, I want to talk about how to almost guarantee an A-star in A-level chemistry. And if you don't know who I am, my name is Khalid. I'm a graduate from Imperial College London. I studied chemical engineering there for 4 years. And for my A-levels, I did maths, further maths, chemistry and physics, and got 2 A-stars and 2 A's. And I got an A-star in A-level chemistry. So hopefully I can give you some helpful advice in this video that would definitely help you to improve your result and hopefully get that A-star in A-level chemistry. And to be honest with you, what I'm going to talk about in this video is exactly what I would do if I were to go back and redo my A-levels in A-level chemistry. I'm going to give you a 4-step process in this video, and if you've watched another one of my videos, which is about how to get an A-star in A-level physics, or if you're struggling with A-level physics, what to do, I'm going to basically go through the same 4-step process that applies to A-level physics and also applies to A-level biology if I were to do it again. And you can see that 4-step process here. We're going to go in depth and we're going to go and talk about each of those stages in more detail, but that is the overview there. The 4 things you need to do to get the A-star is develop an initial understanding of the topic, deepen your understanding through foundational problems, build long-term revision resources with Anki, and then also grind questions out from PMT and Isaac Physics. So with that being said, let's jump straight into the video itself. Now, before we actually get into the 4 stages, I want to talk about time management to start off with, like I did with when I made that physics video. When it comes to time management, most important thing is figure out, first of all, how many hours of lessons do we have per week, right? That's the first thing we need to identify, like in school. So how many hours of lessons per week in school? That's the first question you need to answer. Usually, for most schools, it's about 4 hours of chemistry lessons per week, right? So figure out how many hours of lessons you have per week, and to start off with, what you want to do is match study hours in school. Match study hours in school with independent study hours outside school. Alright, so I could just change this to lesson hours actually. So match lesson hours in school with independent study hours outside school. So if we have 4 hours of lessons per week in school, this means we need to have 4 hours of independent study per week. 4 hours of independent study per week. Alright, and that is the absolute bare minimum, and that's what I think you should start off with. So if I have 4 hours of chemistry lessons per week, I will have 4 hours of independent study per week. This includes time for homework, by the way. This is a key thing. So this includes time for homework. All right. So in these 4 hours of independent study per week that you're spending, this will also include time for homework. Now, for most people, it's about 1 to 2 hours a week of homework. So this leaves you, an extra 2 hours per week, 2 to 3 hours. For true independent study. All right. So essentially, for the 4 hours of independent study that you're going to do outside of school per week to match the lesson time that you have in the week, you want to spend a bit of that time doing homework, right? Which should take you 1 to 2 hours a week, depending on what your school is and like how your school likes to teach, and how much homework your school gives. This might be a bit bigger, but like for average, you like for homework, it'll probably take about 1 to 2 hours a week to kind of go through that. This leaves you an extra little bit of time each week to go through some independent study. And with that, we're going to basically use the 4-step process that we're going to outline today. All right. So in the extra hours that you have, outside of homework, you want to spend that time on the 4-step process I'm going to detail in a second. So hopefully that makes sense. These 4 hours of independent study per week, you can basically decide to split up throughout the week where you see fit. Now, what I'd advise you to do is obviously use the free periods that you have in school as best as possible, because that's when you're going to be quite productive. If you delay this stuff to after school, you're probably going to have less energy after school and you're probably not going to be able to do work as productively. So try to make use of your free periods if you can. And if you also have time, you can put this on the weekend as well. Now, another thing that is also important when it comes to this time management stuff is realizing that if you're not getting the results that you want, if you're not getting like A-stars right now, and you feel like you are being effective and efficient with how you're studying, then the only constraint that you have at this point is the amount of time you're spending on the work. And so if 4 hours a week isn't enough, then you need to find more hours a week and maybe increase it to 6 hours or 8 hours, etc., depending on how much stuff you need to do and how far behind you are, right? So essentially, if you have an effective studying process, then the only thing you need is work ethic and basically time investment. But I think 4 hours a week is a good, basically matching the hours that you have in the lesson with hours of independent study outside of school right, is a good starting point, and then from there you can decide to scale up if you need to. If not, you can keep it as 4 hours a week, and I think that's a good amount to kind of a good amount of time to study for a subject, if that makes sense. So hopefully that makes sense. I think another aspect of time management that I want to talk about is how to split your time between understanding and application. Okay, and I would also say actually understanding, building resources, and application. So let's break up into these three categories. So generally speaking, when you have these extra 2 to 3 hours a week that you're spending doing independent study with our 4-step process, the 4 steps can be kind of broken down into these 3 main areas: understanding, building resources, and application. So understanding is all about obviously making sense of the material, right? Using textbooks, notes, ChatGPT, etc., stuff like that. So textbooks, videos as well, YouTube, ChatGPT, whatever. So that's all about understanding the material. Building resources is all about making the Anki flashcards, right? And I would say application is going through the cards or solving problems. So I would say application is not just about solving questions, it's about actively engaging with the material through active recall or practice, essentially. So hopefully that makes sense. Those are the 3 phases I would say that the 4 steps can be broken down into. And for understanding, I think that should take about maybe 10 to 20% of your time. Again, building resources should take another 10 to 20% of your time. And then application should take about 60 to 80% of your time, essentially, right? If you could sort of, I think the ideal numbers would probably be 10%, 10%, 80%. I think that's what I would say is like the sweet spot. If you can get to this, then that would be great. You can see you want to basically heavily prioritize application, basically heavily prioritize going through questions and actually, going through your flashcards. That's very important. However, you don't want to neglect building your flashcards and understanding the material. It's just that you don't want to spend way too much time on these first 2 phases because it's not really going to get you the results that you want. The key thing that's going to get you the results is actually going through the flashcards and actually solving the problems themselves. Okay, so hopefully that makes sense. So that's basically it when it comes to the time management side, right? You want to basically match what you have in school with the outside of school, right? In terms of time investment. So if you have 4 hours of chemistry lessons per week, it means that you should do 4 hours of chemistry study per week outside of lessons. With those 4 hours, you want to split them up over the week. You can decide where to put them in your schedule. The 4 hours that you have outside of lesson per week also includes time for homework, and so homework would probably take you about 1 to 2 hours a week, which leaves you another 2 to 3 hours a week for actual real independent study. And with that 2 to 3 hours that you have outside of the homework, you want to spend that time on the 4-step process. And when it comes to the 4-step process, you can break those 4 steps down into these 3 main areas: understanding, which is all about making sense of the material and actually really getting to grips with it; building your resources, basically your Anki flashcards; and then finally is application, which is basically going through the flashcards, solving the problems, and actively engaging in problem solving and fact recall of whatever you've learned. All right. So hopefully that makes sense for time management. If you have any questions about time management, drop them in the comments. But hopefully that clears it up. Now, let's talk about the first step in the process, which is about developing an initial understanding of the topic. This is very similar to what we've done for A-level physics. If you have watched my A-level physics video, it's basically the exact same 4 steps that we need to take. Now, to be honest with you, chemistry, I feel like, isn't a very complicated subject, at least for me personally. So I think when I was doing my A-levels, I didn't really struggle with this first step too much. But if you are struggling, then there are plenty of resources that I think would be helpful. Number 1 is obviously the official exam board approved textbook for your exam board. So I got the AQA textbook here. So this is the AQA one, the Oxford one, that I think would be a good one to use. But if you're doing another exam board, have a look at those endorsed resources that are available on the official specification website to find out, what is the best textbook for me. Right? Scan through all the different textbooks, figure out which one is the best for you to learn from, and go with that. You can also have a look at some YouTube videos. When I was doing my A-levels, I used to watch this guy, Allery Chemistry, so I've got a screenshot of his picture there, of his video there. So Allery Chemistry is pretty good. There's also some other good chemistry, YouTube videos out there. There's also another resource that I forgot to add to this, which I think is very helpful, which is called Chem Guide. So I think this one is very good for like an intuitive understanding of chemistry. So have a look at Chem Guide as well, and that they have some very good articles on there to help you understand chemistry, and it actually goes a little bit beyond the spec, which is quite helpful and helps you to actually get a better understanding of the topics themselves. And I also think that ChatGPT would be a good resource to use. in the sense that it would help you to digest and make sense of the material that you have. Now, you have to be careful when you're using ChatGPT. Make sure you're using it in line with the specification. So make sure that the information that you're getting from ChatGPT is specification relevant. And what you could do for this, I think, would be to just grab a screenshot of the specification like I have here, paste into ChatGPT, and then ask questions based and tell it to answer based off of the fact that you need to know these specific things from the specification. So I do think that ChatGPT would definitely be helpful to clarify your understanding. It can also be a good resource to get new examples. So for example, if you don't have many examples of calculation questions from your textbooks, then you can ask ChatGPT to make some more calculation examples, for example, for relative abundance or relative atomic mass, etc. So ChatGPT can be a good resource to help you understand the material when it comes to that. Now, when it comes to this first phase, as I mentioned on my physics video as well, don't take notes. All right, don't take notes when you are going through this first phase. When you are doing your independent study. So remember, the 4 steps I'm talking about is for when you are doing your own independent study outside of lesson. If you're in lesson and you want to take notes to digest what the teacher's saying for the first time, I don't mind you doing that, although it might not be as effective as you might think, but I don't mind you actually taking notes in real lessons. But when you're doing your independent study outside of lesson, there's no point of taking extra notes. It's not going to help you to digest and make sense of the material any faster. And to be honest with you, it would actually waste your time. Now, I say this from experience because when I was in my A-levels, I literally took the A-level chemistry textbook that I was using and I made bullet point notes on every single page of the entire textbook, and it didn't really help me that much. I think I would have been better served just by actually researching a bit more, making sense of the material a bit more, and solving more problems. I think that would be a much better strategy, and that's why I advise everyone who basically listens to my advice to not take notes during this phase, because you already have summarized notes out there on Physics and Maths Tutor, Save My Exams, and there's plenty of other guys out there who have already made summarized notes of the material. So there's no need for you to make your own notes. It's not really going to help you to digest the material any faster, to be honest with you. You can still make notes if you want. It's personal preference, but from my experience, I don't think it's that helpful for you, to be honest with you. So I advise you not to take notes and save that time and actually spend that time solving questions and spending more time in the next phase. So hopefully that makes sense. The first thing you want to do is develop a good understanding of the topic. Make sure when you are understanding the topic that you are using the specification and you're going, specification point by specification point. Make sure you have a good understanding of each thing before you move on to the next point. And that's very important there. Okay, so hopefully that makes sense. Now, once you're done with this first step, you want to move on to the next step, of course. And that is about deepening your understanding through basic problems. Now, as I just mentioned to you, you don't want to make notes in this first phase because it's not really going to help you to understand the material, right? What actually helps you to, when you think about it logically, the thing that helps you with understanding is something that happens in your mind, right? You writing stuff out isn't going to help you to understand. Now, this is like a nuanced point. So you copying down word for word from the textbook is useless. However, I can appreciate someone who is writing down, for example, like a calculation question and is reproducing the calculation from scratch to understand how it works. I can understand that's helpful. So you can make scribbles, you can maybe sketch diagrams or make scribbles or write certain things here and there. What I want you to avoid doing in this first phase is copying down and summarizing in bullet point format the information from the textbooks. All right, that's what I want you to avoid. However, if you want to just write some scribbles here and there and make it very messy, that's good because it's helping your brain sort of process the information, which is fine. Now, the reason why I want you to avoid taking notes is because you're technically going to do this in this second phase, right? So when you're doing these basic problems, the aim is to deepen your understanding. It's to test your understanding of what you just read and you just processed. And it's also a very short mini test that you can take. So just solve these basic problems. They're straightforward. There's no problem solving elements required. And it should be quite straightforward to get to the answer if you have a good understanding of the first phase. Now, when you're solving these problems, the best tip I can give you is try to avoid looking at the notes or the textbook on the previous page, essentially. And try to solve these from memory to start off with. If you can't solve it, then skip it. And then just try and do as many questions as you can in one go. And then once you've finished, then you can go back and try to use the textbook to help you answer the questions. All right. And then once you're done with that, then you can check out the mark scheme and just clarify that you got everything correct. And then if you have any misunderstandings or you got something wrong, you can clarify that from the actual mark scheme itself. Hopefully that makes sense. Now, the reason why I told you to avoid taking notes in the previous phase is technically you're going to do that through these sorts of factor equal questions here. Right. So these factor equal questions here technically are going to get you to reproduce the notes that you would have made in step one if you were to take notes. So it's better to just do this because it's going to, number one, engage your memory, right? So it's going to be a short recall exercise. So it's going to help to strengthen your memory of the topic itself. And it helps you to actually clarify your understanding properly, right? Because if you sort of copy down something that someone's written on the textbook, you might be able to copy something down without actually having understood it. But to answer a question on a concept, you're not going to be able to answer the question on the concept if you don't understand it. So I think answering these sorts of fact recall questions is actually a superior form of taking notes, because it gets you to actually identify what you don't understand and what you do understand a lot faster. So that's why I advise you in step 1 to avoid taking notes. There's no point. You're technically going to do that through these sorts of fact recall questions anyways. And so there's no need. All right. So hopefully that makes sense. By solving these questions, it's going to help you to appreciate and understand the points from the previous step. All right. And what you want to do is basically get as many textbooks and get as many basic problems as possible from multiple textbooks. So my advice is, generally speaking, to get multiple different chemistry textbooks. So I've got this one here from Hodder Education. This one here is from so this one's Hodder. This one is CGP. All right. You can also get the Oxford textbook questions as well. And generally speaking, you want to solve as many textbook questions as possible from as many textbooks as you can, until you feel like you have a very good understanding of the basics, and you have a very good understanding of the previous points there. All right. So what you want to do, by the way, is once you finish solving these problems, go back to the specification and read through the specification and clarify, do I understand each of these things? And if so, just give them a tick, right? Pretty much. So hopefully that makes sense. Now, another thing that I want to say is you want to ramp the difficulty of the problems that you're solving in this step. So in this step, when you're doing your basic problems, don't just like solve all the textbooks, the questions from all the textbooks. What you want to do is build the difficulty over time. Because generally speaking, different textbooks have different difficulties of questions involved. So generally speaking, I think Hodder usually has harder questions than CGP. So you want to start off with CGP questions to get a feel of the topic, get an initial understanding, and figure out what's going on. Once you're done with CGP, you can move on to Oxford textbooks, try some Oxford textbook questions from there, because they're going to be slightly harder. And then finally go to Hodder Education, try those super hard questions from the Hodder Education textbook. And if you ramp the difficulty over time, then you are basically increasing your problem solving skills slowly as you're improving your understanding of the topic itself. All right, so hopefully that makes sense. So that's basically it for step 2. You just want to basically do some basic questions, do as many of them as you can, and the more you do, the better. And if you don't understand the actual how to solve the problems, it could be because you don't have the foundational understanding, or it could be to do with the problem solving side. So you need to kind of identify where it is you're going wrong. Is it the fact that I don't have a good understanding of the basics, or is it the fact that I need to just give this question a bit of time and improve my problem solving skills? All right, so hopefully that makes sense. Now let's move on to the third step. So once you've done the basic problems, right, and you've initially understood the material properly, what you want to do is, again, clarify that you've got a good understanding of this material by just going back to the specification and just subjectively deciding, okay, do I have a good understanding of this, this, and this, right? Based off your experience with just doing these basic questions from the textbooks, you should be able to answer this quite comfortably, right? So you should have a good understanding at this point. Now, once you have a good understanding, a solid understanding of these specification points, what you want to do now is build some long-term revision resources with Anki. Now, this is extremely important. And this is, I think, where I went wrong in my A-levels for chemistry. Because what I did was I used paper flashcards, like physical chemistry flashcards, and I was going through them quite frequently. Whereas if you use Anki, it's going to be the most efficient way for you to remember the information that you've learned. Again, I've said this many times, the most effective way to remember anything that you've learned over a long period of time is to use space retrieval practice, basically. It's to space out the retrieval of the knowledge that you've just learned. So, for example, let's say you learned something in A-level maths, right, about vectors, right, about the vector equation of a line or the vector equation of a plane, and you wanted to sort of remember those formulas and how to solve those sorts of problems. If you just look at it once and you understand the textbook questions and you really understand the concept, but you don't do space retrieval practice, it doesn't matter how smart you are, you won't be able to remember those ideas in a year's time. And the only way for you to remember it is to do space retrieval practice, honestly. Like, everyone will forget stuff if they don't do space retrieval practice. That's just how our brain works. And so what you want to do when you're doing your A-levels in chemistry and physics, and even maths if you want, is to make Anki revision resources, so that way you remember all the information that you've learned over a long period of time, so that way you don't forget it, and so you don't need to revise as hard for topic tests and mock exams, because you're remembering all the content that you've learned over the year. Now, how to get started with Anki? Use these 3 resources to get started. Use Anking, the Anki subreddit, and the Anki manual. All right. Search for these 3 things on the internet and use those things to basically get started. Obviously, do these things in sequential order. So I would say start with Anking if you have 0 experience. Then once you're a bit more advanced, go to Anki subreddit, and after that, you can use the Anki manual if you want to get some extra information about how Anki works. All right. Now, a key point when you're doing this third step, when you're building your revision resources, is to look at exam questions to understand how each specification point is tested before you make your flashcards in the first place. So, for example, if we wanted to make flashcards on this section 3.1.1 about fundamental particles, let's say we wanted to kind of identify how this information is tested. So what we're going to do is look for questions that will test this sort of knowledge. Now, what we want to do is go to Physics and Maths Tutor and scan through the different booklets on the topic and identify the questions that test this knowledge. So we found one question right here. This question is about atomic structure, and it's actually about an atomic model, the Rutherford model. And so this question is actually testing this knowledge right here from the specification point. We can see that clearly. What we want to do is identify how they are testing the knowledge, right? So you can see here that they're asking for you to state the differences between different atomic models, right? What's the difference between the current atomic model that we have and the Rutherford model? And they've given you a sketch of the Rutherford model in the question itself. So you need to look at the model and identify the 2 features that are different from here. Now, a key thing that you want to note is that there are 2 things that are highlighted in the actual question itself, right, in the figure. And so if those 2 things are highlighted in the figure, then that's giving you a hint that those are probably the 2 things you need to kind of discuss. So you can see here that the 2 points they mention are relevant to those 2 individual sections, right? So you can see here and here. All right, so this first section, it says current model includes neutrons and protons as opposed to just having a positive nucleus, right? So the current model actually distinguishes that we also have neutrons in our nucleus. It's not just a positive nucleus. And the second difference is that the current model, we have electrons in energy levels, whereas here we just have like shells of electrons essentially. So hopefully that makes sense, right? Those are the differences there. And so once you understand that, then it makes it easier for you to identify what should be my flashcard so that I can remember this knowledge that I've learnt, right, about the atomic models in a way to get the marks when I see an exam question about this topic. So what I noticed from this question is that when I make my flashcard on this specification point here, I need to clearly distinguish between the different atomic models. So I need to be able to distinguish clearly what the differences between the models are. And so when I'm making my flashcard, that is what I want to say in my question. So my question potentially for this would be, outline the 5 different atomic models proposed over time, include the following in your answer: the name of the scientist who developed the model, the experiments and observations that led to the model being proposed, and the limitations of the model and why we had to develop a new one, right? And so if I'm able to reproduce this, then it would, and especially this last point, if I'm able to identify the limitations of each model, then it would help me to distinguish the different models from each other and basically identify what the differences in the features are between the different models. So hopefully that makes sense. Of course, I made this flashcard in like 5 minutes. I didn't actually think about it too deeply, to be fair. So I can appreciate that maybe this flashcard isn't the best. However, hopefully the point stands, right? The point stands that I want you to basically identify how they test the knowledge, and then how could I best make my flashcard to satisfy sorts of the exam questions that might come up about this specification point. Hopefully that makes sense. Now, what I would say, as a resource to make the flashcards, you want to use summarized notes like from PMT and Save My Exams as your basis to build the cards, because they're going to be the most efficient way to do so. But what we also want to do is cross-reference this with official textbooks to check everything is covered. So the summarized notes from PMT might not cover absolutely everything. That's what you have to keep in mind. And so you want to cross-reference with textbooks and other resources to make sure that you understand all of the different models that AQA or OCR or Edexcel want you to know for by the time of the exam. So hopefully that makes sense there, right? So definitely make Anki flashcards. When you first start out, you might not be able to make the best flashcards, to be honest with you. And to be fair, this flashcard isn't the best in the sense that it might have too much information packed into one single flashcard. So you might want to break it up into multiple different ones. I just wanted to kind of get you to understand why I'm doing this and the thought process behind how I want you to make the flashcards. I want you to make the flashcards in a way to get the marks from the mark scheme and in order for you to get the answers correct. And I don't want you just to make the flashcards just to summarize this information here. Because if you just summarize this information here, it might not allow you to get the marks from the mark scheme when you're actually trying to answer actual exam questions. Okay, so hopefully that makes sense. But regardless, you still want to make Anki flashcards. Just doing this will set you apart from 99% of people who are doing A-level chemistry, because no one is doing this. I promise you, no one is doing this. So just to get started with Anki, using these resources that I've mentioned there, if you want to actually remember all the information that you've learned long term. Now, the final step is to grind questions. So once you've done step 1, step 2, and step 3, you have a solid understanding of the material that you've learned. You have a very deep understanding of the material. You've also practiced a little bit of problem solving and a little bit of exam style questions from the textbooks themselves. And you've also built and retained the knowledge that you've learned of the concepts and of the topics that you've studied over an extended period of time. So at this point, you have a good understanding and you have a solid memory of all the information, and you're able to reproduce it instantly. And so what you need to do is just practice exam questions to improve your exam technique, essentially. So when you're doing these questions, right, you want to use them, do them from PMT, which is Physics and Maths Tutor, and Isaac Physics. I would say to use Physics and Maths Tutor extensively, to be fair. So I think put about 80 to 90% of your time on this, and then put about 20% of your time on Isaac Physics, to be honest with you. But prioritize PMT. This should be your priority. What you want to do with this is do the new spec questions first, and then do the old spec questions second, right? And as you're doing these questions, it says here, how do you want to tackle the questions? What you want to do is obviously try the questions as they come up. And if there's any question that you've solved before that you know how to answer, like for example, state how many protons, neutrons, and electrons are in this thing. If you know how to do that and you're very comfortable with that idea, then there's no point of trying that question out, because you're very comfortable with actually, doing that task. So you can skip that question there. Or if it's a definition question that you know how to answer, then there's no point of answering that if you know what the definition is word for word, right? So skip questions that you've solved before or you know how to solve, and only focus on questions that get you to apply the knowledge in a new way, or new 6-mark questions or 4-mark questions or weird questions essentially that you're not sure how to answer, and practice your exam technique by solving those questions there. Now, another thing that's important is you want to modify your flashcards if needed and if that comes up, because when you're doing these questions from PMT, you might identify that, okay, like I need to say these key phrases to get the marks. So you might have an explanation question saying, describe how the ionization energies of these things, like what is the trend of the ionization energies in this period? Then what you could do is modify your flashcard on your ionization energies that you've made before in step 3 in order to get the marks from step 4. So hopefully that makes sense. What you want to do is make your flashcards in a way to get the marks from the mark scheme, and use the mark scheme to sort of help you identify the key phrases, the key words, the key statements you need to make to get the marks. The reason why I say you should also use Isaac Physics is if you want some more experience with solving complicated calculation questions or application questions that get you to apply your problem solving skills. Isaac Physics is a good platform for that. Again, you probably don't need to use this as much as you need to do for physics. So Isaac Physics is very helpful, but I think PMT, if you just prioritize that, you should be fine. When I was in my A-levels, I got an A-star in A-level chemistry. I think I got like 90% overall, just by using PMT, paper flashcards, and textbooks. So I didn't do anything fancy. I think if I did Anki flashcards, it would have made my life a lot easier. So this is a very important step. Make sure you're doing this. But that is pretty much it for how to get an A-star in A-level chemistry, to be honest with you. There's 4 steps there. You want to basically develop a decent understanding basically develop a decent initial understanding of the topic through the textbooks, through some research online, through the resources that you have available. Once you feel like you have a decent understanding of the material and you have a good grasp of the basic concepts, you want to really test your understanding of the basic concepts and deepen them through lots of basic problems, right? Do as many basic problems as you feel you need until you have a good understanding of the concepts. My advice for phase 2 would be, because I know a lot of people skip textbook questions, what you want to do is, let's say for example you solve the CGP questions and you're comfortable with that. If you look at the next textbook, which is Oxford, and you feel like the questions are way too easy, just scan through and see which of these questions would I not know how to answer, and pick out those ones and solve those ones specifically, right? But step 2 would help you to improve your understanding of those foundational problems that you've just through those foundational problems. Then build your long-term revision resources with Anki, so that way you remember all the information that you've learned over an extended period of time for the 2 years of A-level. I promise you this is going to save you a lot of headache in year 13 when you actually have to prepare for your final exams. And step 4 is to grind questions for using Physics and Maths Tutor and also Isaac Physics. Now, Physics and Maths Tutor should be your priority. This is where you should spend about 80 to 90% of your time when you're doing step 4. And if you want some extra practice to work on some problem-solving skills in chemistry, Isaac Physics would be a good platform for that. Have a look at some of those chemistry questions there to basically improve your problem-solving in chemistry. So hopefully that makes sense. It's basically identical to how you study for physics, and I think biology is also identical to how you study for chemistry. Um, Honestly, it's not that hard to actually get an A star in A level chemistry. I think a lot of people mess up because they don't have the right exam technique. To be fair, so I think where you want to basically be very very cognizant is step three and step four. Right, you want to be very very careful with step three and step four. What you want to do is remember the information in the right way to get the marks. It's not just about remembering the information just holistically, right? About like what are the models, like what the atomic models are. That's good. It's helpful to know what the atomic models are, but you need to recall the information in the way to get the marks from the mark scheme, and that's why you need to do step three and step four very carefully, in order to get the marks from the mark scheme when you're answering your actual exam questions there. But honestly, chemistry is pretty chill. It's a good subject. So good luck with that if you are doing A-level chemistry. If you have any questions, drop them in the comments. And if you have any other video requests, drop them in the comments as well. But I'm probably not going to do one for biology, to be honest with you, because I feel like it's the exact same thing as how you study for chemistry. And I'm not qualified to speak on that because I didn't do A-level biology myself. But I'm pretty sure if I were to take A-level biology, I'd do the exact same thing that I'm doing here for A-level chemistry, to be honest with you. So hopefully that makes sense. And also, if you're interested in getting into a STEM course at UK Uni, click the link in my bio. I've helped many students to improve their results in A-level maths, chemistry, physics, and I've helped someone get an offer from Cambridge to study engineering. And so if you're interested in that, click the link in my bio to join the program. Otherwise, hopefully you found this video useful, and I'll see you guys on the next one.